On a passé en secret, machin, texte, et ça compile plus.
Ah, ça compile plus, mais hier ça compile.
Ça compile très bien, et je l'ai recopié, je l'ai remis là où il était à l'origine.
Ouais.
Et là, ça compile. C'est chez toi ton projet.
Ouais.
Il faut donc rappeler aux gars qui sont dans la. Qu'il faut se mettre dans le carré.
Ouais.
Le carré.
Ah ouais, voilà, c'est le micro, ouais. Là, le
Le
carré. Ouais. La blue sheet, c'est déjà parti.
Yeah.
On commence?
C'est quoi comme IETF
Pardon?
Le code.
Peut-être qu'il n'y a pas de. C'est déjà.
We are going to start. If you can please get to your seats. Je fais la petite intro.
Ouais, tu peux dire pour notre toilette.
Okay, so this is the first meeting actually for the Lpwan working group. So we welcome you in this room. Can you please get to your seat? We are getting started. Okay, so this is an IETF working group meeting. This means that we comply with the best practice about the IPR. If you are aware of some IPR that on some subject which is discussed today, we ask you please to come to the mic and mention it, or after the meeting, come to the chairs and mention it. This meeting will be recorded. It's being actually sent live. So it's available on Mitico. If you go to the IETF agenda page, you will see this link about the meeting today and all those small icons. You can use those icons to download the PDF format of all the slides that you're going to see today. People who are not in this room can actually use those links as well to join on Jabber, on Mitico, etc. And meeting takers. So as every IETF meeting now, we've got an Etherpad page. So we ask you please, if you want to join this Etherpad page, you can add some minutes live. You can also see what's going on, and if you think the minutes are not correct, you can mention it as well on the minutes. Remote participation is through Mitico. And we're going through the agenda.
So this is the agenda for today's meeting. So we'll do the short introduction, and then we'll be mentioning that we have two charters, two items on our charter, and today we'll be addressing both of them. So the first part is presentations that are related to the Lpwan overview document. And here we'll be stepping in for Stephen, who could not come to this meeting for personal reasons. We also have some presentations from the technology providers because we could not have an attendance from one of these technologies. We preferred to have it for the next IETF meeting. So there is a document that has been published there. So if you want, you can read the draft. It's really detailed, and it's a really nice one. So this is the agenda for today. If you have no items that you would like to add, we can move forward. So we are now a working group. So our working group was announced and approved exactly 1 month ago. And we are very happy to be working with our AD, Suresh. So please join the mailing list if you have not done so yet. And the full charter is available on the link over there. So we'll be focusing here on the two charter items that we were chartered to do for. So the first one is an informational document which is describing on some selected LPWAN technologies. So we have decided to focus on 4. And the goal is to have technology representatives of all these 4 major LPWAN technologies, and we have them here. One of the goals of these documents is actually to provide us with common characteristics and things that we should be doing for these LPWAN technologies. So to give us what are some of the basic characteristics which we should be aiming. Because we already have a lot of work going on this topic, we needed an editor. So we made a call on the mailing list, and after several volunteers, we decided and we chose Stephen Farrell as the editor for this document. And today's the big part of today's meeting will be actually related to this charter item. We'll see a lot of presentations on this topic. The second item is where we're actually going to produce a standard track document to enable compression and fragmentation of CoAP of the IP stack, UDP, IP, UDP, and CoAP, which is designed for LPWAN networks. So please go read the full charter. It's really interesting. So, and today we will actually see some presentations that are related also to this second charter item. These are the milestones. So we are really in a very we are on a very tight schedule. So, but it is doable, and we will do everything possible to achieve this. Please go and participate, read the drafts, and participate to the mailing list. So, just to sum up what we are supposed to do from our charter. So, today we will be discussing a lot on our first charter item, the LPWAN overview document. And it has really advanced. We will have some overview of this, a lot of presentations, and we will have a last call for workgroup adoption in April next year. The second item, charter item, which we'll be working, is the compression. So the first document is IP UDP compression and fragmentation. So we hope that we'll be able to adopt this as a working group item in December this year. And have everything necessary to have a last call in May. And then the second part of this charter item is the CoAP compression. And so this will come a little bit after the IP and UDP compression call for adoption. And we hopefully will be able to have a last call in June 2017. So as you see, very tight schedule, and we hope that you will help us deliver this topic. So we can move on if you have no comments for this.
Yes, and I will step in from Stephen to introduce his draft. So the way we have structured this is we're going to introduce the draft as a whole right now in a few slides. And since the draft is mostly about the 4 technologies and the gap analysis between those technologies and what the IETF could bring, we'll leave the floor to 3 of those technologies. Like we said, Laura is actually not present today, so we delayed that presentation for the next time. And then we'll talk about the gap analysis as well. And then we'll go back to the main document, and we'll discuss about the adoption process and what's missing in there and what needs to be added, etc. So just a quick presentation on this draft. So this is actually a merge of text which is coming from the 4 technology draft and a draft by Anamina Bureau about the gap analysis for the LPWAN technology. So all those people are co-author, and as you know, you can't have too many co-authors on the main page, so they are moved like in a contributor section, but they are all actually co-authors of the document. The structure right now is kind of basic logical. You've got an introduction, you go through all the technologies. we are looking for a terminology, an architecture that would represent the different architectural objects that you can find in common in those technologies. And there is a security consideration. It's a usual draft. And as we are chartered for, the 4 technology that we are talking about are LoRaWAN, NB-IoT, Sigfox, and WiSUN. So the goal of this document is to go informational. At the moment, we are chartered to make it RFC. There was this question on the table for a long time. And as the charter stands right now, it says go to ASG in April. So that's a very tight schedule, as Alex said. So the goal is to help people who don't come from the Lpwan technology to rapidly get up to speed about those technologies, understand the trade-off, why we are for, what different coverage they have, and how they apply in the real world. And with this, we'll go first to Anna. So Anna, you've got 10 minutes, that's correct? Yep. So if you can, you're the first speaker now. If you can stay in this, there must be a square in front of.
It's over here.
Where is it?
Yep.
Oh, okay. So please stay within the square so you're on TV.
On the other direction, the other side. The other side.
Hello. Well, today I will try to show you only the difference between the first version and this one. Well,
maybe you can take out the mic. Yeah, but stay in the pink.
Yeah, stay there. Okay. One thing we have do in this new version is merge of the draft Minaburo LP1 gap analysis and the draft of Gomez LP1 IPv6 analysis. We have worked together with Carlos. We take the base of this document. This new version is the gap analysis version 1. We add all the IPv6 analysis of of Gomez draft. And we eliminate all the solution, the draft Gomez given in his first version. We only keep the analysis. And this is the table of content only to show that we have worked in the new things also. We add the architecture that we have already discussed a little bit in the mailing list. We add the draft in the Lpwan and IPv6 discussion. And we also add a new thing about the RUC compression, because there are so many questions about how we don't use this solution for the compression of the headers. So the first thing that we add in this new version is a benchmark for LP1's technologies. When for example, I tell you we are using a high-speed network, you are thinking about megabits per second. When I tell you I'm a low-speed network, you are thinking about kilobits per second. When I tell you I have an LP1 network, you have bits, 1 or 2 bits per second, then some bits per day, then this changing the scale, okay? Then we need to rethink how we adapt the actual solutions about timers, about delays, about buffers, latency of networks with this new scale. Well, this was an example, but I think that it's enough to have understand the problem. The next point is the architecture. We have the same elements, but each technology name it differently. Then I start a discussion in the mailing list about how we can make a consensus, or how do you want to name each part of this architecture. Then what we more or less get is that the nodes, I don't know if we can. Yeah. The nodes, there are several thousands. We can call them hosts. Somebody said we can call the things because we are in LP1, and it could be very funny to have things instead of hosts. But we don't get really a consensus in mailing list, and I ask you if you agree about this terminology, please send a mail or say it in the micro. Then we have radio gateway. That is also node B for some technologies. Then it's more clear for us to call it radio gateway, which is joined to the network gateway. That's a router. But the proper name of router is network gateway. Then I would like to know which terminology we would like to use. Then we have a server, this server for authentication, security. Then I put it AA server, and the application server that more or less all the technologies call it at the end. What is also new is what I added is why or what are the problematics to use the ROHC solution. Then the first, or some of them, are the header size, because we don't have 2 bits or 2 bytes, sorry. We have many different sizes of header. Some of them are not compliant to LP1s. When we realized route header compression, the nodes were not constrained. This means we were not available with low batteries. They have to have memory process that we don't have in all the nodes of LP1s. They're also managed with a sequence number. That makes a little bit complex the solution. We need to adapt this if we use it for co-op compression. And we need, for example, to take it out from the framework to make it more dynamical. Thank you. Questions?
Questions?
Juan Carlos Zuniga. So thank you very much. Very nice work in merging the 2 documents. What do you guys think are the next steps? Do you think it's getting ready? You still want to add more value? Is there something that we need to work on? You mentioned the terminology. That's definitely something we need to give you feedback on. But is there anything else we need to do as next steps?
I think that we need to work with Stefan for the working group document in order to add all this information as good as possible to what is needed. Perhaps not all that is on the draft, okay, but all this analysis can give the overview of the LP1 needs, requirements.
Okay, thanks.
I would like to actually ask the group how many of you have already read this document, because it has been around for quite some time, and it will be like an input to some parts of it will be an input for our first item charter, and especially so. How many of you have read any version of this document? Okay, so quite a lot of hands up there, or at least 10 or 15 people. So because there is this question about the terminology, and I think that this is a thing that we should discuss also and decide on the mailing list, because in our LP1 overview document, I think that it will be nice if we can have at some point some consistent terminology in which we will know exactly what we are talking about. So if you can please pitch in on the mailing list about what do you think about calling the hosts things, for example. Do you agree with this? And then once we fix this, we can work with this.
Suresh Krishnan, I'm just trying to figure out like in what form this will get included in the final deliverables, right? So there's like 3 deliverables like written on today. So where do you think this will get folded into? Like, or do you want to just keep this as working group item and then not publish it? Like, what is the goal for that? I just want to figure it out.
For this document,
the terminology pieces.
we have this big problem that we don't have a consistent terminology, so I think it's necessary to publish a terminology document because it's going to be used by all the other documents that this group produces. So
no, but by publish, what do you mean? Is this like something you want to keep as a working group document? So this is something we've been discussing in the IESG, right? Like, so are all the documents that are required by the working group, do they need to be published? And that's why, like, you know, we took a lot of time working on the deliverables in the charter, right? So I'm just trying to figure out, are you going to fold it into one of the things in the charter, or are you just going to keep it as a working document?
well,
Right.
we discussed that earlier this day. We don't have a definitive answer, and we
Okay.
can talk about this.
Just
But
something to think about for you.
the plan as we go is have this merger document by Stephen, have a terminology section in it, and publish it as RFC. But if there is a problem on the way, but that's the way we are chartered. We looked at the way you worded the charter for us, and we found that we have publication to the IESG, which seems to indicate that we are going on the RFC path.
Yeah.
So, and the terminology section is needed there.
Okay, that's perfect. Yeah. So the idea is like to make sure. So one of the things like we've seen is that like documents get hit to the IESG and people say like, why didn't you do this before, right? Like, so the idea is to set the expectations now to the group like that, what you're gonna do, right? But I don't want the answer today, but it's something I want you to think about, right? Like how you fold in. So your answer is good to me, but it's just something that also take up with the group. Okay. Thanks.
Thank you.
Okay. Thanks, Anna.
So, Dominique, I said this Stephen's document will incorporate a terminology section, which will have those wording. It's not a specific terminology document. So, okay.
Okay, so once again, we had a change from our initial agenda because Stephen could not make it here, unfortunately, for this meeting. So there is a document for the LoRa one and for the LoRa specification. It will be presented on the next IETF, but this time we decided to skip it and give more time to the people that are here. So thank you.
So you get 15 minutes plus Q&A. You don't have to use them all.
Yeah, no worries. I probably don't need them all. Thanks. So, hi everyone. Juan Carlos Zúñiga with Sigfox, and just a quick review of the presentation I gave last time in Berlin. So, what is this Sigfox architecture? Well, basically, we have the central LPA gateway, which is cloud-based. We call it service center, but it's equivalent to what we are apparently calling here a gateway. Our network is comprised of cooperative radio gateways, base stations that use MIMO technology. So basically, they receive and combine the information back in the cloud cooperatively. It's basically a public network, so pretty much like cellular. It's not meant to be used for private network usage. It's a public service, just like NB-IoT, let's say, will be. There's a central global authentication, so there's no roaming requirements, and there's no need for handoffs or any re-authentication attachment and so on at layer 2. The application is transparent to the network, so right now the packets are delivered from the object to the customer apps transparently. We discussed last time about the uplink PHY characteristics. Perhaps we don't have to go into all the details, but just to give you an idea, we're talking about uplink rates of 100 to 600 bits per second, depending on the region where we are operating. Different same modulation scheme, but with a good link budget that gives us long range and good indoor coverage. Well, the rest, I guess, it's from the ISM bands, basically, so different bands depending on the region, ETC, FCC, and similar around the world. For the downlink, both cases have 600 bits per second transmission in both ETC and FCC zones. Again, the link budget is similar, to 153 or better, and same thing, we're working on the different frequencies, but at the same ISM bands. For the ultra narrowband overview, just because some of you may not be familiar with this, it has some characteristics that is high resiliency to interference. So this is good for robust operations since we use the ISM band with other technologies. There's some anti-jamming capabilities because of the frequency hopping and the way it has to work. So there's always a good spatial diversity that gives us gains of about 20 dBs. But again, some details that may not be 100% relevant for what we do here. This is maybe something that we need to pay more attention, which is the layer 2 characteristics. The framing is different because of the different characteristics that we have to operate upon. We have different framing on the uplink and the downlink. So as you can see, there is the preamble, frame sync, device ID, and so on, but they have different sizes. On the uplink, we have 12 byte. On the downlink, we have an 8 byte payload. Again, fragmentation and encryption is done at the application layer. The globally unique ID is 32 bits. We have limitations due to the regulatory constraints of about 140 uplink and 4 downlink messages a day. This can be moved a bit depending on the region, but that gives you an idea where's the ballpark. The security, well, there's message authentication and code attached to the unique ID. The key management is provisioned, but again, the encryption and so on are carried out by the application itself. For the network deployment, well, some people were asking where it is, and several countries, 25, I think, right now. Some of them are fully covered, some of them under deployment. Cell sizes of about 50 kilometers. Current applications, this is something that we had a little discussion on the list. Giassi was asking what exactly is the use case, or how can we characterize the applications, and as I answer in the mailing list, is very different depending on the application. So it's not easy to give you a number, right? So again, it's not the same rate that a meter will transmit as compared to a cow, or to a, I don't know, fleet management, tracking, pool measurements, and so on. So this is something we have to keep in mind, that the number of packets it's very, very different. However, I thought it was a good idea to put some payload size examples, like for instance, GPS coordinates, we need 6 bytes, temperature reporting, 2 bytes, speed reporting, 1 byte, object state reporting, 1 byte if we want to report the actual state, or 0 bytes if we just want to do a heartbeat. So in summary, the system is definitely tailored for low-end, very low-cost devices. So the idea is to complement other technologies, LP1 or not, that may be playing on the higher end. It's working on a public network. There's multi-vendor support for the devices. There's some university programs to collaborate with research programs and so on. We have complex SDR, software-defined radio base stations, MIMO-based. And the idea is to make simpler certified modules at about $2–3. The reason I'm saying this is because, again, the idea is to go to the very low end. So all the complexity is burnt on the network, so that the device can be as simple and as dumb as possible. The radio interface is optimized for low power uplink communications. There's support for downlink, as I showed you, but there's definitely optimized for uplink. Channels are asynchronous, so no need to synchronize or to send keep alives or to attach, you just send a message. There's unlimited sleep time because of that. Downlink communication is on demand by the device application. So it's a pull, not a push model. And the interest that we have in the group, well, just like the scope says, we want to define common LP1 management features, common security features, and common application profiles. Okay, so thank you very much. Is there any question?
I have one about the draft as well, because you have published a document. So what is the intent, the goal, coverage? I mean, can you talk a little bit about your draft and encourage people to read it?
Yeah, well, the draft describes what I just presented in a little more detail. I guess the idea of the draft, in my understanding, similar to other drafts, is just to pass information on to the overview draft, so that the best or the most relevant pieces can be extracted. But beyond that, I don't think that the draft has long list. Was that the question, or?
Yes, it is. My interest, I found that this draft is particularly relevant because we are lacking other information from Sigfox. So it's actually the place where we can find all this information. LTN, I understand, will publish some file-level information in this year, right, or next year. So there's a plan for the lower layer standards to be shipped by other groups, but the upper MAC and the thing on which the IETF will be working on, I mean, this is basically your draft, right? That's the place of reference where we'll find it. So I think it's particularly interesting to have this draft in this group.
Okay. Yes. So definitely, yeah. There's work, and the draft has the references to the ETSI LTN work carrying on in the TG28 of the ERM group in ETSI, and that is advancing. So there's expectations to have it almost completed for next year. So that should be fine. Meanwhile, definitely, if we need more information, I can keep this draft or put the information in the draft if we need to revise this one to let the IETF work continue, basically.
Yes, I wasn't clear, and maybe you can clarify, but I wasn't clear about the scope of the LTN work. And can we expect from that document to reflect the whole stack on which the IP packet will be put, or does it stay a little bit lower on the PHY and lower MAC? And do we have all the stack at LTN, or because I read some exchanges explaining that no, LTN is more interested in the lower layers and not really the upper MAC.
Okay. Well, my understanding is that yes, whatever is defined there, we can base IP upon that. But again, if there's some missing pieces because of some details that maybe escape, we can add them in this draft and then pass them on to the overview very, very easily. So we can fill that gap.
Exactly.
But in general, yes, that it's focusing on the layer 2, layer 1, and this would be, well, IETF would be on layer 3 and above. So if ever there's any
there is a gap,
shim
we
layer
can cover it.
that we need to define the ability.
Good. Thank you.
Okay. Thank you.
Any other question? Thank you. So Antti is on.
Okay, so we can move on to the next presentation, which is by Antti, who should join the online. He's already there.
Can we try?
Okay, so Antti,
Can you speak now?
so can you request to come to the mic? Okay.
Can you?
So now, try speaking now. Okay, again. Hello, no, we cannot hear you.
Shut doesn't work.
Okay. Unmute doesn't work. So we would need some help support from the Meet Echo people there. Okay, yeah, thanks. Antti, can you request actually? But he's on the screen. Can you? Okay, let's see what the. They're talking to Antti. Okay.
Again. Okay.
Normally that he should appear as. They are looking at it.
Okay, so why don't we switch and come back to Antti later?
Do you have any? Yeah. Okay, so let's switch with Bob Haley's presentation first, and then we'll come back to Antti. So, MJT.
Yes, stay in the ping box, Otherwise you're not on TV.
Okay, well, at least I'm here. I think I'm here. I just came in from the IEEE 802 meeting in San Antonio, so I think the body is here and the brain is somewhere over the Pacific. So I apologize if my energy level is a tad lower than it normally is, but Anyway, I'm Bob Hiley. My affiliation is the Wi-Sun Alliance, but I think probably many of you also know me as the chair of 802.15. So what I'm going to do a little bit here is just give you a flavor of the Wi-Sun field area network. And what this is to show you this thing is not quite in focus, is it? But that's all right. Neither am I. I used to chair the Communications Task Force in 2030, which some of you who worked in the smart grid area might remember was a guide, which is sort of a compendium that really defined architectures that were suitable for smart grid applications. And in that, we defined a concept called a field area network. And this just demonstrates what that concept is in the grand scheme of things. And so what Wi-Sun has done is really implement that. It started out as something that was aimed at the smart grid community, but it was a very generic solution to field area networking, which actually is quite appropriate as you start to realize, how am I going to implement smart cities and a number of things like that from a networking perspective, something that's reliable and extremely robust. Kinds of applications are ones that are not a bit surprising and ones you've seen before: AMI metering, transformer monitoring, distribution monitoring, EV charging stations, load control, outdoor lighting, gas and water metering, distributed generation. It's a whole bunch of SCADA stuff. And then just think about anything that you could think about in terms of outdoor IoT. Also, though, you could think of this as a home area network too, but it's not there yet. In terms of just a broad architectural overview, this looks quite familiar because it's based on 15.4G. And that's this part down here at the bottom. Is this got a laser pointer thingy in it?
Yes, the top button.
Very faint. It's based on 15.4G and what we refer to as 15.4E, which was a series of Mac enhancements. That's all rolled into 15.4-2015, if you go looking for it. And then sitting above it, an adaptation layer of 6 Lpwan, and then it gets into some really familiar territory here on up through TCP and UDP. Application layer independent. So we don't do much with application layers, except we do try to promote a few of them that we think are going to be beneficial to promoting field area networking. Really, in terms of a general summary, it's an open standards-based solution, and these are the four. The two that are mainly used is IEEE 802 and IETF, although we got a little bit of TIA in there and a little bit of ETSI. The architecture is an IPv6 frequency hopping wireless mesh network, so and it's got enterprise level security in the form of 802.1x, which I'll speak a little bit more later. Very simple infrastructure, which is really the whole concept of 15.4. So that results in low cost and low complexity. Because of the fact that it's mesh frequency hopping, mesh networking solution is very superior networking robustness, reliability, and resilience to interference, mainly because you've got high redundancy in frequency hopping. So that can get around a large number of things. Excellent scalability because, again, the mesh just builds on itself. Long range and energy friendliness. It supports multiple global license sub-gigahertz bands from 433 megahertz right on up into the 915 and 950. Multi-vendor interoperability, since that's the whole point of having a defined specification and a PICS and a certification program. And then, of course, what we're working on now is very low power modes. There's a lot more need these days for something that has battery-powered nodes. That does result in some differences in the way you go about things. So we're developing a situation where we permit long-term battery operation of network nodes. This is the fan stack overview, and again, this is sort of like what I showed you before, but in a lot more detail, along with the various protocols that are using. I'm not going to dwell on this a lot. Yeah, you'll have this when you download the presentation, but I will go through the protocol layers on here. In the physical layer, it's FSK modulation is what we use in 15.4G. The data rates are typically 50 kilobits per second on up to a maximum of 300 kilobits per second. The node-to-node range is up to several kilometers where regulations permit. The several kilometers, of course, is open field. You're not going to achieve that in an urban environment, but then again, you're going to have much more in the mesh networking and the frequency hopping to get around that. But you can have different node densities depending on the class of environment you're trying to approach. There is optional forward error correction for better link margin, and the specifications cover Australia, Europe, India, Japan, Korea, North and South America, and Southeast Asia at the moment. So rather broadly distributed around the globe. In terms of the protocol layers, moving on up to the data link layer, the frame does support full IP payloads. That's something we implemented in 15.4G. That's the only one of the amendments in 15.4 that does support full IP payloads. It's got a 4-octet FCS for good error detection. It's got a decentralized frequency hopping, and where that following ANSI 4957.200. It's also got channel blacklisting. So as you go through on the frequency hopping, if you find one that has got a lot of interference on it, you can blacklist that channel so you're not wasting time and energy going to it. You just work on the ones that remain. It's got link layer encryption and integrity checking for privacy and message verification. So there's a lot of security built into this, and an optional layer 2 multi-hop layer built on ANSI 4957.210. Continuing, the adaptation layer is 6LoWPAN. 6LoWPAN, one of its principal things was to deal with the fact that most of 15.4 does not do full payload, so how to deal with fragmenting the packets and reassembling it as a full IP payload. That's not the issue, but what we do use it for is IPv6 header compression, which is something that is particularly important, as well as UDP header compression, fragmentation where it's necessary, neighbor discovery, and routing support. The network layer is IPv6 and DHCPv6 address management. And then the routing that we're using is roll ripple, and security is L2 integrity check and encryption. We do use 802.1x over IEEE 802.15.4, and that's what's characterized in what we just completed, which is the recommended practice for key management protocol, which is IEEE 802.15.9. And then we do use certificates for mutual authentication. That's the unique manufacturing certificates that get built into everything, so you go through a more robust authentication means. In terms of, let's kind of put together some general comments. The Alliance feels there is significant value in this activity, so that's why we're here. The spec that we've got was developed to service this space as well as a lot of others, and we're going to continue to expand its capabilities. And as already included, though, since this really started out as something that was built on IEEE 802.15 and IETF standards, many, not all, but many of the needed networking elements are as a result of that long-standing relationship between the two organizations. So there's, but that's not to say that there aren't a lot of things more that we can do. So some of the things the Alliance hopes to accomplish out of this is awareness. I mean, we expect to learn things as we go along in this, but one of our missions is to help ensure consistency of approach, because at the end we want things that sort of all work together. We have some relevant experience. We expect to share that. We really want to address coexistence issues, because a lot of these things are going to be used in the same kind of markets, and we got to figure out how all this stuff works in a complementary way. Because it's IP-based, the fan already interconnects easily with Ethernet and Wi-Fi through routers, but it would be useful if the same thing can be accomplished with other approaches, because that would vastly simplify the general interoperating of networks. Things that we would like to see, the Wi-Fi Sun fan and hand profiles both use 6LoWPAN, primarily for header compression. Full IP frames are supported, but header compression is useful for optimizing bandwidth. So I think there's more that can be done on the header compression front than what we've got with 6LoWPAN. And very useful to include UDP and CoAP compression methods also, not just what we talked about before. And not all nodes on a Wi-Fi fan are necessarily routing line-powered nodes. So by optimizing the compression for battery-powered nodes, that would be another one of the mechanisms we could use to extend battery life. So all these things sort of relate to each other. And that's it. So that kind of gives you just a general flavor overall of what we're doing and why we're here.
Do we have questions?
Oops, a bit low. Hi, stand back. John Dowdle from Airbus. I'm sorry, I'm slightly new here, so forgive me if I make a silly comment here. If you're routing within your network and you want to go to some other network which is running some other routing protocol rather than Ripple, would you normally do that directly or through some kind of mediation device to stop
through a mediation device?
Yeah, to stop the overload onto the. Okay, all right, thanks.
Okay, so if there are no questions, I would like. Sorry.
I have one or two questions.
Yeah. Oh, okay.
First question is related to your last slide about compression. So I understand that you're using 6 Lpwan HC at the moment. The work that we have in mind here doesn't have a constraint of being backward compatible with LPWAN. That's a non-goal, meaning that if you were to adopt work that is done here, there would probably not be a backward compatibility with what you already have.
Yeah, it all depends on when it happens. You know, if it happens in sooner rather than later, then the market isn't that broadly developed yet. Yes, there would be the forklift upgrade and some of the stuff, but now's the time to do that kind of stuff. If it happened a year to 2 years from now, then we're stuck.
We have a very, very aggressive schedule.
Right, that's why I like about the aggressive time schedule.
So in this room, people be aware we have to make our aggressive schedule here.
And I'll help do it.
Okay. And the other question? The other question is, so the way we plan to publish the work is this aggregate draft that Stephen Farrell is putting together for us. The other technologies still have introduced a separate draft on their own purpose. I mean, and we appreciate they did, right? Do you plan to do one as well?
Yes, we do.
Okay.
I was just lazy. No, I was busy.
It rhymes.
Yep, and I just want to iterate once again for our solution. In our charter, we are specifically dealing with star topology. So the compression that we're developing and all the things that we're doing now is star topology. So, you know, and I think that it will be also in Stephen's, so Stephen, our editor, we are really grateful that he accepted this. If you could facilitate his work and point out exactly, you know.
Because this can be configured in star configurations, but you can also take advantage of what the mesh capability allows you to do on top of the stars.
Of course, yeah.
Okay.
Okay.
With luck.
Thank you very much.
Thank you.
So we can go back to try connecting with Antti. So Antti, if you can hear us, can you please try to request presenter again? Yep. So can you request now? He's requested I need to press. Okay, try again.
So while we are waiting for that, one question that came in via Jabber was, is the Wi-Fi work available?
Bob Hiley, available in the sense of, can you publicly get? Well, I tell you, it's easy to get. Yeah, sign up as an adopter member of Wi-Fi, which is no charge, and then you can get it. So it's sort of like a getting contact information when you download a white paper on the thing. So it's a no charge thing, but it is available to anybody who does that little step.
Okay, you say it's no charge, but how much lawyer time do I need to make that happen?
Tom's lawyer time.
Yes.
None.
Okay, so once again, Meet Echo help will be greatly appreciated.
Anybody speaks a language, sign language? No. Usually we know how to press buttons. Only one.
So, Antti, I'm not sure if you can request to click somewhere to request to speak.
Push to talk. C'est pas, il n'y a pas de faire des fois.
I mean, they did the test before that and it worked. So, if anyone is on Jabber, can you please just talk to the Meet Echo people there? Okay, so we wait a little bit. So in the meantime, just to sum up why we are seeing all these presentations here, well, all these presentations and the text that in the individual submission drafts, most of the things that you've seen here will be actually included in the Lpwan overview document, which will be then which will be accepted. We'll do a vote about this to be as a working group item. So this is our first deliverable part of our charter. If you want to ask questions, now is the time on these technologies. Stephen is the editor, and he has some questions for us later. We'll discuss this also. And he's requesting. So. No, we cannot hear you, Andy.
Okay, so let's move on again, I guess.
No. Okay, so I propose that we move on with the other presentations, and we'll get back again because Antti he will be presenting the NB-IoT technology. So there is a draft there on NB-IoT, and it's really really interesting. A lot of interesting information. So please do read these drafts. Do read the Lpwan overview document in case you have not done so yet. So let's actually, Pascal, it's our turn to get to. So we are stepping in for Stephen Farrell, who is our editor.
Okay, so as you've seen, we have this first chartered item, which is to write this consolidated document. And as Alex mentioned, we have elected Stephen Farrell to be the editor, but there are a lot of contributors. And our goal for today is to basically get feedback about what goes in the draft and where we stop, how big we make this draft, what kind of information is most relevant inside the draft, so that we keep things square and not too heavy. So what Stephen is working on right now is what you can see on the screen. So trying to get the text more to the point and removes all the extra. He had questions about what needs to get in there. And so the first question, if you have, I just come to the mic, please. The first question there is, do we go through all the radio frequency stuff? And we talked about that with Alex. And basically the point is, if you come from another group at the IETF and you've not done too much radio, and usually, I mean, we are at layer 3, we don't do so much radio. I think it's pretty important and interesting to see what your ultra-narrow band is and how it plays versus something which spreads across all the bands, and where do you need coding gain, and what do you save or get back from UNB when you have coding gain, and all those games. I think it's quite important in a few pages if you can get access to that information. So my answer to Stephen is yes, we want this information. But if people in the room thinks it is not relevant, then it's time to speak. No. So second point was about the gap analysis. So any comment about what goes in there? Do we track the issues that are listed in the gap analysis? Any comment on that?
Actually, before moving with these questions, I'd like to ask the room, how many of you have read at least one of the technology individual drafts? So we have the, okay, a good third of the room, I would say. So when you read these technology drafts, did you appreciate having the radio information there that was mentioned? Was it something you said, it's nice? Yeah. Yeah, people say yes. So I think that we have the answer on the first question.
Well, the second is really too high level right now about the gap analysis. I think we have to continue with the work as it stands and give enough time to the room to read the document, because it's pretty fresh out of the press, and so it's probably not widely read as in its latest state. Terminology is a good question, and actually that's the one that Suresh has asked us. So as we go from now, the point is we need a terminology, that's for sure, and we don't want a separate document to hold just the terminology, so that would be this document. Feedback is good, okay. Next slide. Decide target. So that was a question by Stephen. I think we have a contract with the IESG. It's called the charter. And so Stephen is on both sides of this charter, so he pretty much knows. Can we make this date? I expect we can. And I see a lot of contributor. I see a lot of activity. So for now, we can deal with last goal in April. Yep. So what's the balance between this draft and the technology-specific draft? My answer being that the technology-specific draft are personal submissions, so people can put whatever they like in there. We don't control that too much. We don't enforce anything. On this particular draft, what we want to enforce is that it's level balanced between the technology, gives similar information so that you can understand why you would go for one particular application to one particular technology. Information like deployment model, information like bandwidth, information like coverage, information like tolerance to interference, all this is important for a certain application. You need to be able to find in a simple place where well, all this information you want. So that's the goal for this document. And whatever else people want to put in their individual submission is their business. I mean, the group appreciate all the work, and the more you put in there, the best, but we don't enforce anything. So that's my balance, basically. In one case, the group controls the balance, and that has a limited and precise scope. In the other documents, you do what you like. So, yeah. Terminology, we discussed that, so it's a yes and a yes. The big discussion about gap analysis, so you've seen Anna's presentation. How far do we go in there? Will this text stay? So this is one for which we really need feedback from the room. I mean, in the ultimate version of this document, do you expect a gap analysis, meaning that this document is the source for the work next? Or do you see it? Do you see that the gap analysis goes because this is a document about the technologies, not about the gaps? And for now, it's the placeholder. But how do you see this moving in the future?
Juan Carlos Zúñiga. So I think that this document definitely is a basis the one that gives information that is not necessarily obvious to understand why we are doing the standard solutions that we want to do after. So for that, to me, I think we have to definitely understand what technologies we're targeting, what is the issue that we have to solve, and what are the common interests from these technologies. Mm-hmm. So to me, those are the three elements that are missing, so that whatever standards track document comes up, people can really understand, okay, this is exactly what we're targeting, what we're solving, and what was the interest from the community. So not basically, yes, tech gap, but also common interests.
Oh, so you're mostly pointing that the taking things that are in common in the four and making that a common section would be good, right? So that you can actually say, oh, we've got these common needs or these common requirements on the IETF or something like that. And that goes in the gap analysis, or that goes in a new section?
Well, not necessarily like making a compound of the technologies, but basically once you describe where you want to play, then you can say, okay, because of all those reasons, now we want to send a packet this size with that timing constraint.
Okay, let's continue on the mailing list, but there's a point here there that, because this really affects the structure of the document maybe. So it's good to discuss that on the mailing list.
Shri, one clarifying question. So gap analysis with respect to what? Is that?
Oh, so we've got 4 technologies, and basically, and you saw Anna's presentation a few minutes ago, what can the IETF bring to help to grow something more powerful? And that would work, that is not already present in those technologies, and can help if it's done in a common way for those technologies.
So is that feedback coming from the system architecture where the respective SDO is working on, or you want that to be identified here and then it goes back to the system group or the SDO?
Okay, whatever we do here, as to if an SDO wants to adopt it later, then that's when it gets into their standard. As long as they don't adopt RSC blah 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 into their standards, it's just paper.
Suresh Krishnan, just to answer Sri, like it's what needs to get done in the IETF. That's what you're trying to identify, not somewhere else.
Okay, missed that question.
Matthias Kovac, Siemens. So I like these documents, so including the technology-specific drafts, because they give good information about this technology. So it's really hard to get this information elsewhere, because most of these alliances work kind of in the dark, or, well, proprietary. So these documents are very good for that. So I would like to keep this as a really good reference that can be used on and on. So it's really an informational document that can be used for a long time. So I would like to keep out kind of the note-taking for the work done in the group here out of this. So not that it's just issues and then we can discard it, but something that stays. So in terms of gap analysis, it would be maybe interesting to say, yeah, and this technology leaves this open to the implementer, and this technology leaves this open. So it gives you the information what is kind of missing to adapt everything, but it's not in terms of, okay, and here we have to do this and that. So it's really something lasting.
So when we publish, that must go away, right?
Yeah, or this way. So I mean, you can have some editorial notes and so on, but also keep it in there, but more for understanding, to really understand these different technologies. So that would be the nice part about yeah, putting good work into these documents.
Yeah, good idea. Yeah. Okay, so now basically these are all the questions that. Yeah. So no, we'll go through this on the mailing list. I mean, if Stephen was there, he would. So we have a number of issues, but we don't have so much time.
No.
And so
we discussed them all.
Yes.
We discussed all these questions until now. So the big question for us now is, do you feel, yep, so this is, okay, I need to advance here. So this is the big question for us now. Are you ready? Do you agree to adopt this as a working group item? and so that we can do the work on this document. We have the editor, we have the input, and from what we asked to the working group until now, a lot of people have read at least one of the documents that got merged into it. So,
do you feel confident that we can start making it a work group document? Please raise a hand if you are. Good. Sense of the room is good. So we'll call for adoption on the mailing list, and we'll have it confirmed within 2 weeks. Good.
Okay.
Thank you so much.
Thanks.
NT again? No?
So NT, we try again. Going to you. We'll have a couple of more occasions, but let's not miss this one. Yay. Okay, so pressing the button.
Did something happen? I mean, didn't he get in touch with?
Yeah, they tried. I hope I'm not launching nuclear missiles somewhere, because I've launched many. I started some world war somewhere.
I won't vote for you anymore. You're too used to the button.
Yeah. NT, no, we cannot hear you there.
Okay, so try, and during that time I will be introducing the second.
Yeah.
Okay. So basically there was 2 big parts for this meeting. The first part is about Charter Item 1, which is this document about all those 4 technologies, and that will be useful for the community inside and outside this working group. And the second piece is a standard track document that we must produce. And as you've seen, the sending to ISG is chartered to be in May, which is absolutely aggressive. And well, the good thing is that we have great work started. And Laurent Toutain now will come to the mic and tell us about this work. So the goal is to compress all the IP up to CoAP, right? That was one of the points that Bob Eiley made a little bit earlier. And there you go. So the idea is now the charter item is to compress all the way to CoAP and compress dramatically more than what we can do with 6LoWPAN. No? So you've got 20 minutes for the SHE work and 10 more minutes for the other work.
Okay, thank you. So I will talk about the draft on IPv6 static header compression. So here is version 0, but it's the third version of the document, but the group changed its name several times, so I'm stuck in version 0. So when you do compression, you have to adapt to your environment to have a very efficient compression. So we first try to think at the characteristic of Lpwan. So we have seen it in our document, but what is very important here is that we have a star topology, so no routing inside the network, so we can do something that is optimal. We don't have to carry addresses or things like this. And we have also some nodes that are constrained, and we know which applications are running on this node. So it's easier to compress because we don't have some very strange traffic. What is very important also to do is to have a very flexible compression. This way, with a flexible compression, we can adapt to the traffic we want to compress, if we want to send some option or not. It depends really on the application. So here is the architecture, so it's what you saw before. So we have the thing here that is sending on, we're using radio, and it arrives on a radio gateway. And then we have a tunnel that sends a message to a network gateway. And then we have another tunnel or to the SCHE, so the compressor. So it can be a tunnel or the SCHE can be included into the network gateway. So we have different possible architecture, but as we say here, we have no routing between the thing and this compressor, decompressor. So that is a lot what we want to do. So one objective, of course, is to have something very, very efficient, because we have done not a lot of room, and one goal is to compress IP, UDP, and maybe more into 0 byte if it's possible, and in some case we can reach this goal. We have also to cover legacy things. It means things that never be aware about IP, but we can put this thing into the IP world if we want. But of course, we have also to take into account the fact that we have to stay in the IETF model, and everything can be is a node and can have routing capability. For example, you have a thing that is a router between a LP1 network and a Bluetooth network. So you have to take this thing into account. So if we resume that in this scheme, so we have here the legacy, what I call the legacy architecture. So we have a thing that is producing or receiving non-IP traffic. And then we go to the SCSC compressor-decompressor, and then we create something that is compatible with the IETF architecture. And the other thing, the other way, is to have compression and decompression on both sides. And this way, we are aware about the IETF stack, so it could be useful for routing, or if we have some security functionality, we can get the IP address and things like this. That could be important. Yeah.
Sorry, Juan Carlos, do you want to take questions while you speak? Yeah. So just regarding your terminology here, on this side, basically the uncompressed traffic would look the same, right? So you're making a difference between legacy and IETF model, but I think to me, at least the way you're describing it, it's the same on this side. What you're addressing is devices that were not IP aware before, right?
Yes.
So that those devices are the legacy devices.
Yeah.
So this is a legacy model, but in fact, this interface is the same in both.
Yes, in fact, it will be the same way to do it. The only thing is that, for example, here, that is a very important thing when we develop the protocol, is that we cannot have negotiation here to negotiate a context or to make the things learn about things, because she will be not aware of anything about compression.
Here.
But okay. What we will do here will be compatible with that, if we do it well.
Okay. Okay, so then basically all the right-hand side is the same on both top and down figures, right? So there's no difference between legacy or IETF model.
And on this side, but when we design the protocol, we have to take care of legacy things, and so, as I say, we have to avoid negotiation or
okay, okay, yeah, fair enough. Thanks.
No, legacy is because you ask. Yes, it's this architecture. Okay, so as I say, one important thing is that we know what traffic we have on the network. So the things, normally you put it someplace and you cannot very easily upload the code or install application. So you know what you are generating. So that's a way to have something that can be put easily into the context. And so fields are classified on this is something very classical, static, so well-known things, so you don't have to send them. Some dynamic things, so you have to send this information. And you have also something you can recompute when you receive it from other information. So that's the main characteristic of each field. So to give an example of that, so we have, normally I have a nice animation here, but it has been disappeared. So normally what happens, so you have here uncompressed packet that arrive on the thing or on the compressor. So here you have a set of rules. So first thing to find is to identify the rule, or the rules that you need. And when you have this rule, you just send the rule number. On the other side, since you have the rule number, you're able to reconstruct the header and send it on the other side. If you have some dynamic information, then with the rule number, you can sense this dynamic information to reconstruct the header on the other side. So for the vocabulary, this set of rules will be called a context, and what we send in the wire is a rule ID. So here is an overview of the architecture. What is important for us is not to do the compression or the decompression, but is to set up this context on both sides, and will help the compressor and the decompressor to behave as we want. So more vocabulary, and it's a simplification from the previous version. So now we have only, so a rule is a set of fields, and each field has 3 values. The first one is the target value, the one we want to compress. We have a matching operator that allows us to compare the field value with the target value. And we know this target matching operator, we say, okay, we have a match or we don't have a match. And we have a compression-decompression function that will tell us how to compress this or how to decompress this in the opposite direction. So one rule is to say that when you receive a packet, so here is the matching operator, you compare the target value that you have in your context with the field value. If all the fields are matching, then you select the rule. If one of them doesn't match, you go to the next rule. And if there is no rule that match, the packet is dropped. So currently, we define 3 matching operators. One is ignore. It means that you don't care about the value, so you don't do the matching. So it can be viewed as always truth. One is equal, so you compare the target value and the field value, and if it's okay, it becomes true. And we introduce another one that is most significant bit. So you compare the L most significant bits from the target value and the field value, and if it's okay, the match is done. Yeah.
Dominique Bartel. I think when you write, if no rules, the packet is dropped, you mean the packet is dropped from the compressor. It doesn't mean the packet is dropped on the network, right?
No, it's dropped from the compressor.
So it's just sent without compression.
Maybe.
So it's not dropped, it's sent.
Yeah. I don't know, because it depends. It depends on the implementation. If you have a big packet, you cannot send it in Lpwan. So maybe you have to do something else. For the compression-decompression value, for IPv6 and UDP, we developed some functions. So for the first one is not send, so it means that you don't send it because normally you have in both contexts. Value send, so you send the value. And the complementary to MSB for a matching operator is LSB, so you send here the bit you don't test when you are sending it. And then you have 3 functions that are used to compute fields in IPv6 UDP. So you have the length that you can measure, and you have the checksum that can be used in some case for UDP if necessary. And something that we took from 6 law is that you can also reconstruct the interface ID value using the MAC address or the layer 2 address for the thing and for the destination outside of the LP1 network.
Laurent?
Yes.
So as you know, in RFC 6281, we compressed the UDP checksum, but that was a long dispute to be able to compress, to remove a UDP checksum. And the thing which allowed it to pass is that the frames where we elided actually have a message integrity check, a MIC at the end, which is usually 4 bytes. So much better than the UDP checksum. So we said, hey, if we have this 4 bytes MIC at the end of the packet, why put a 2 byte MIC inside the packet, right? So that allowed us to elide it. Now, if we can elide it here, we'll be asking for balance. I mean, what do you put instead? And if there is nothing which compares to UDP checksum to protect instead of the UDP checksum, then this one we may not be able to elide it, right? So that will be optional to elide it.
It's optional because when you have a field, you select what you want to put in front of them, which function. So for example, if I have a UDP checksum, I can use send value instead of this. So it depends of your implementation, what you really have. So if, of course, maybe you can mandate to have another checksum for UDP for that case, or rely on layer 2 checksum from your technology because you are sure of it. So but we are not forcing one behavior. You have all this stock of functions, and you use the one you want for compression, decompression. So here is a simple example. Maybe I will skip it or just, so you have this packet arrives. It doesn't have any field that match with the target value, so it is dropped, as you want as Dominique called it. This one is okay. This value, the 12 first bits of these 2 fields are matching. So you just send this value, and here you can reconstruct the field.
Hello.
And of course, you have to send also the rule number.
Am I disturbing something
As
here?
I say, if it can be done at layer 2.
No, I'm not.
So for example, in LoRa technology,
So you cannot
it can
hear
be
me?
a port. So you there is a very small impact for the compression. So here is a list of functions. So I will not go into the details. It's on the draft. But for example, what you say about UDP is written here, is that here you can have a send value instead of a compute checksum. It depends on the behavior. One other thing is, for example, up limit. You can send any value and reconstruct it with a specific value on the other side. Maybe it works, because here we don't have a risk of loop in this kind of technology. So maybe it's something we have to discuss more, but
just
it's some possibility.
It might be a problem on our end.
So then we develop a kind of formalism to set up this context, and one good one is Young to do this. And so we have this approach that say that the array we saw before can be viewed as a Young module, and we have here. We have here the different rules. In a rule, we have different fields with a position, and also a target value, matching operator, a value for the matching operator. For example, for MSB, you have to carry the length, so it can be done here, and the compression function here. And you have also a value, for example, for LSB. So this is things. It can be done with COMI, so I will not go into detail, but we have a seed value for here, and you can use it to have a very compact way to set up context in both sides. For example, here, things needs to know is prefix network to compute CRC or thing like this. So using IPatch maybe FOD, we can set up this context, this prefix on the thing.
Yeah.
So this is a very brief description. So my question now is, so we send, so it's lasts for, let's say, 6 months that we have some draft about HC. So we don't have a strong opposition for this proposal. So I would like to know if we can go to a working group
We'll be asking this question. Before we ask it, can I ask you another one, which is about implementations? So do you have a running implementation of this?
So we have one implementation from Aclio, and we are in a code stand, and we maybe have another implementation from university in Colombia or the country about this.
So this means that there is already a return from implementation on what you have, because you have simplified the thing between 0 and 1, right? Good.
Yeah.
Okay, so does this approach look reasonable for the people in this room? Please raise your hand if you like the approach. Yes, we seem to be going on the right path, and that's pretty good because we have only a few months to make it.
Yep, there's someone.
Yes, we have a question.
Rahul, Huawei. So my question is, the rule ID is directly carried as part of the MAC payload, right, as I understand?
The rule ID can be put in layer 2 information, like, for example, F-port in LoRa 1 technology. But if it's not possible to put it in layer 2, then it can be the first byte you send on layer 3.
But isn't there a requirement for a dispatch header of some sort? Because SCHC might receive a regular IPv6 packet or a rule ID. So how do you differentiate between them? So a regular gateway, say for example, there is some sort of, my point is there is some sort of dispatch header required to carry this flow ID so as to understand or to differentiate between a rule ID versus a regular IPv6 payload.
I don't think we have a problem, because if we look here.
Yeah, here on SCHC.
So here the rule ID will be carried only on the thing.
Right. So is it not possible that the thing can actually also send some other thing, not this thing. This is a highly compressed thing, but the other thing might also send a regular IPv6 packet or a 6-LoWPAN packet or whatever. So doesn't it require a dispatch header to be identified, which is needed on the HCHC?
I think the rule ID can be viewed as a dispatch. So if you have different values, you can use them. For example, you can mix some things that have to be sent using SCSC and other things that can be sent directly. In that case, you have a very simple rule in SCSC.
So the current topology or the current architecture, if I understand it correctly, all the things have to talk using rule ID or the context mechanism. There can be a heterogeneous mix of things, which certain things might contain context information only, and certain other things might contain a regular IPv6 information can also be carried from other to the same SCSC gateway.
What is very difficult to see is how you can send, for example, IPv6 directly on that link. But
okay, maybe if I can just intercept here. So maybe in some cases it could be a dispatch or something. Here the question is, does the general approach seem reasonable? Do the people approve this? Then this is of course a detail we must figure out. Okay. And this is the work that should be done on the mailing list. I completely agree with you that there should be a part of the document. So the question was, do we adopt it as a working group item? And when we adopt it, of course, we do the work on the mailing list. And I will be very happy that you clarify this in the next version of the document. So until now, I think that we had a Sorry, Suresh, you wanted to pitch in on this?
No, that's what I. So it's like we're adopting it, as long as it's interest. And just to answer you, the answer is yes. They all send the same thing, because this is on the specific deployments and the technologies, you decide you're pinning it down to this thing for sending, right? So you won't see regular packets on the wire, so you don't have to distinguish. So that answers it.
Exactly.
But we could reserve rule 0 to say uncompressed, and just to Laurent's point, just in case.
Do you need that?
Okay, so I got the impression that in the room there was a consensus of adopting the documents as a work group item.
We'll call on the mailing list.
We'll call on the mailing list.
15 days by now, we'll have an answer.
Yeah. So thank you, Laurent, for this, and we'd like to invite Laurent to tell us we would like to hear the rest of the story with co-op.
So you were too fast, actually. You had 3 more minutes, so we can all meditate a little bit and start over. Or try until, I wouldn't try until later now, because we have the co-op discussion, so maybe we can move to the other draft, which is SCHC. Do you have another acronym like SCHRUNK?
You are my master with this.
Okay.
So here it's something that is more... It's difficult to do co-op compression than what we have in IPv6 and UDP, because we have good example of doing compression of all these protocols for many, many years. But for co-op, it's something totally new. And we have a lot of difference between what we found in IPv6 and in UDP. First thing is that we have a flexible number of fields in each messages. So it's something that is more difficult to handle. So we have options, of course. We have a token also that can be here, but cannot be here. We have request and response that can be different. For example, in a GET request, you put a path, and in a response, you don't have it. So the format will change from both sides. And I think what is also important to see is when we are doing co-op, it's what we are doing on the thing. If the thing is a co-op server, if the thing is a co-op client, and all that questions. So if it's a server, for example, it will receive requests from client, and this client can use very long identifier. So maybe we have to do something to reduce the size of this identifier when we have to send it on the Lpwan link. So is this on something also? It's to optimize all the traffic and don't send a lot of acknowledgement when we are doing a request. So to go back to that scheme, so yes, for example, proxy means that here we have this architecture. So we have a thing that is still a legacy thing, which is sending a value. And using SCSC, we can generate something that is compatible with the IETF architecture using, for example, IPv6, UDP, co-op, and the value. But here, maybe we will receive hack, and of course, the thing will not know what is a hack. So here we may have to act like a proxy. On the other situation where we have co-op awareness in the thing, then we have just to compress and uncompress things and data, and also the acknowledgement. So what we propose here is to define new compression decompression functions that will be useful for this situation. So one is a static mapping, so that can be used either as if we have a thing as a client or a server. So the goal is to reduce a value from a big value to a smaller one that we will send on the link. And in the other side, we will take this small value and we create a larger one, for the larger one. So it can be used for co-op code, for co-op path, for IPv6 prefixes, so if we want. We have remapping, so we can see it here. For example, here with a co-op code, we have a very clever way to code the 3 bytes of HTML into 1 byte in co-op. But in fact, we are using right now only 31 or less than 31 values. So maybe we can code it with a remapping into 5 bits instead of 1 byte. And it depends also on the application. For example, some application or some co-op server may only use a get, so we don't have to code the other one. So maybe we can have also something smaller with static mapping. Remapping is something that can be used, for example, when your thing is a server and is receiving requests with, for example, a message ID or large token or large token. So what do? The compressor will receive this value and will allocate a smaller one. We send this small value on the link. Of course, on the other side, we cannot recreate the original value, but if there is no semantic on the thing, on the values, just the only goal is to be unique. So we maintain this uniqueness, and then when the thing will answer, it will answer the same value, and here we are able to reconstruct the original value. So the client on the other side will see nothing. So this is one proposal. The other proposal is what I call entropy reduction. So it means that for observed values, for example, you have increase that can be very big, and the goal is to reduce to an increase of 1. So this way we can use shorter value for the observed. And since we observe just some increase, it can be a possibility to reduce the size of what we are sending. Of course, it's not mandatory. You can select it or not, depending on the applications that run on your network. So here is a small example. So we have a more detailed example in the draft. But here, for example, we have an IP, we have a co-op header with no regular header here, no token, but here we have 4 bytes and then the path value. So here in the rule, we can say that we continue to send the type value as is. We compress the code into 5 bits, or yes, 5 bits, and then we send the message ID into 1 byte. And this way, we compress the co-op header that is quite larger here into 2 bytes on the link. And here we have the answer. So this is some proposal. Of course, we need a lot of work to have something that is cleaner. But I would like to have we like to have the vision of the group about this kind of things for core. Okay, but
can I? So I'm trying to tie this with SCHC.
Yeah.
Because here you're not using context, right? You're using a more 6LoWPAN-ish approach of taking bits. Or
here you have the same context. You have a target value, you have a matching operator, and the CDF.
Okay.
And you can have before you can have UDP IPv6 values too.
Okay.
So it's an extension of the previous one.
Okay.
So Krishna, so how does this get chained to the lower layer compressed headers here? You're just showing the co-op, right? Like, is the goal to be able to compress the whole chain together?
We can do it. It depends of where you do the compression, but we can, if we have a compression in one point, you can put before UDP an IPv6 header, and this way, when, for example, you receive a packet, then you can create your header using the value you have in the target value. So it's complementary of the previous one.
But it's independent, right? It's layered. I mean, because with 6 Lpwan, we have merged the IP and UDP layers, right? I mean, you have to decompress them together. But here, you can really decide if you want a big decompressor and then you do all the work, or you do the IP, you handle it, and then you decompress the co-op and you handle it, right?
Yeah. So, and there is also, since we need 2 specific documents, they are separated.
Which is good.
Okay, that's fine. So I just wanted to know like if it's going to be independent, and your answer is yes. Okay.
Juan Carlos Zuniga. So, well, my first question was the same, like how independent or dependent was this from the previous one? So that was answered. Thank you. The second one is related to you mentioned there's some implementation you were working on. Is this part of that implementation as well, or where you're playing with the IPv6?
Currently, it's just IPv6 and UDP, but
you're planning to add this on?
Yes, for next IETF, I think we have an implementation of that.
Okay, thanks.
So this actually is a very new document, I think, and the first one was there for maybe 6 months or so, but this one, I'd like to see how many people have read the document until now. Oh, surprisingly big number for me, at least 10 people. And how many would be interested in actually contributing work and reading it and at least doing comments into it? Okay, a little bit more people, so that's nice.
I mean, just one point, Alex, is when those documents get adopted, we're supposed, usually we pick the original authors, but actually we are entitled to discuss about the authorship and get new authors and recommend new authors in document. So please contact us as well, maybe privately if you wish to be co-author, and let's talk with Laurent about this.
Matthias Kovac, Siemens. It's a question about the general direction of this approach. So the compression basically works on removing a lot of flexibility that the protocols provide, especially here with the mapping of co-op. So does it make actually sense to separate this, to have something at the lower layer, the networking, and then co-op compression on top? Or can you actually combine those, that you have like context that already gives you, for instance, the resource that is targeted on the device and so on? So to really have just one approach how to compress everything to co-op, because as I understood it, to then connect to the greater internet, you want to use co-op anyway for the complete solution. Is that right? Well, the first question, do you want to use co-op as the interface from the internet for the complete LPWAN solution? So I see nods there.
I don't. Yes, I think it's more a question to the chair than to me. We can do co-op, or we can do something else than co-op. We have all this flexibility, so we don't mandate a specific architecture. And when you are sending things, we can also compress things or not compress them. It depends of your profile you are defining.
So, okay, so you're still keeping the door open to maybe have a different one to compress HTTP2, and that's why you have this separation.
Yeah.
Okay, then I understand. Because the idea was, if you want to say, yeah, it will be a co-op interface anyway, and you combine it, I think you could get better results, because you remove a lot of flexibility already anyway, so why not get rid of the last bit of flexibility?
Yes, but when we are in this kind of environment, we have to remove flexibility to have very compact things.
Yeah, sure. And then my question was, is it worth to keep this last piece that actually doesn't give you much, because you're planning for co-op anyway? So
okay, maybe we can discuss that on the mailing list, because it's not very clear to me right now which bits you would really save by integrating those two. I see the value of keeping them separate. I don't see the win of integrating them that you seem to imply there is. So maybe that could be discussed on the mailing list to get enough details so we understand.
Okay.
Yeah. Okay, thank you, Laurent. And we can go back to trying with Anne.
So we'll be asking you to read this document in the next 2 weeks, because we'll probably also be calling for adoption on this work. Because actually we have, what we see is we have one chartered item, we have two documents, which the two documents together actually achieve the charter item. So I see the need for calling for adoption for both documents. I like the idea of keeping them separate if it's not too bad for the charter. So we'll probably be calling for adoption for that document as well. So what about that?
Okay, so thanks, Antti. Let's try once more.
Yes!
Oh.
Okay. Thank you. It seems there's a bit delay on this.
Oh, okay. No problem. So I'll get back to your... Well, this is the music of the joy that we all feel that you will talk about in the IoT. So can you see your slides?
Yes,
and we are perfectly in time. You have 15 minutes plus 5 minutes questions.
Yep.
Right. But
So
there's
just say
like
next slide and
10
I'll change the
seconds.
slide for you.
Okay, so I'm Antti Ratilainen and I work at Ericsson and I've been working with narrowband IoT this year, I think. So hope I can help you understand with some related restrictions of narrowband IoT. And so the narrowband IoT targets the so-called massive MTC use case where the requirements are the following: that the cost is low and the energy consumption is low, data volumes are low, and then there's a massive number of devices. And maybe we can move on to the next slide. So here we have some design targets. So the device cost is like less than $5 per module, and the extended coverage. So we have a minimum coupling loss of target for 164 decibels, and the battery life should be longer than 10 years, and the capacity, well, that's rough numbers, so hard to say, but for the devices per household and 55,000 devices per cell, and the uplink reporting latency should be less than 10 seconds. And let's move on. So the idea is to target the implementation in existing 3GPP networks, so it would be easy to implement in existing 4G or earlier G networks. And it's applicable on any 3GPP license frequency band. There are 3 deployment modes we can see on the right-hand figure here. We have a standalone, which basically can reuse the GSM bands. And then we have a guard band deployment where we use this guard band between 2 LTE bands, and then we have an in-band deployment where we deploy basically inside this LTE frequency band. And we have OFDM basically within these LTE carriers, and it's now with OFDM we have the orthogonality and common resource utilization, and the maximum user rates we can reach is 30 kilobits per second in downlink and 16 uplink. And well, maybe we can move on to the next slide. So here we have some overview. As I said, there are 3 deployment modes, and the bandwidth this takes is 200 kilohertz. On layer 1, we have a FDD only with a half duplex user equipment, which is the device or host or that. Yeah. So and in downlink channels, we have narrowband physical downlink channel over this 180 kilohertz bandwidth, and the random access is preamble based on 3.75 kilohertz. And on uplink, we have either single tone transmission with two options, 15 kilohertz or 3.75 kilohertz, and in that we also have the option of using multiple tones, so 3 or 6 or 12 tones of 50 kilohertz each. And for the actual transmission block size, so how much we can transmit at with single transmission, basically in downlink, it's the maximum is 680 bits in downlink, and in uplink it's 1000 bits. And the minimum I haven't said here, but the minimum would be 16 bits. And for layer 2, okay, for layer 2 we have single process adaptive HARC for both uplink downlink, and then there are two optimization options. We can use the non-access stratum or then the user plane. So in narrowband IoT, this control plane optimization was a new feature, so we don't have to use the user plane, which reduces the signaling and that's active time of the UE. And the MTU size the layer 2 takes from above is 1500 bytes. Then there are these extended idle mode discontinuous reception features. So basically the UE can stay up to 3 hours asleep when it's in idle mode, while in connected mode the discontinuous reception cycle is about 9.2 seconds. And we can move on to the next slide. So basically about the network deployment, the maximum coupling loss of 164 decibels. We have example link budget for uplink transmission here in this table. And basically this what we're looking for in urban scenario. We have deep in-building penetration, and in rural scenario we have long range, like 10 to 15 kilometers. Yes, and we will move on. Next slide. Okay, so here we have some more layer 1 characteristics. So the highest modulation scheme is QPSK, and as I said, narrowband IoT is now specified on license bands, and the operation is narrowband, so 180 kilohertz bandwidth. We have these 3 deployment modes. As I said, maximum transmission block 680 bits in downlink, 1000 bits in uplink. For coverage, we have coverage enhancements, which means basically using repetitions of these transmissions, and we can kind of repeat the same transmission multiple times, and the maximum for these repetitions in downlink is 2048 repetitions, and in uplink it's 128 repetitions. Yes, so next slide. For layer 2, as I said, the supported MTU is 1500 bytes for both this non-access stratum and access stratum optimizations. We have RLC protocol in layer 2, which performs error correction, concatenation, segmentation, and reassembly. And the error correction happens to ARQ, and also the segmentation. So basically this RLC takes this MTU, whatever the upper layer delivers, and does this segmentation into these small transmission block sizes, which the maximum was 680 for downlink. And then the RLC segments this 1500 bytes into these smaller packets for the layer 1. And then in the receiving end, it again reassembles these smaller packets into the MTU size, which was received. Then we have a non-access stratum and access stratum kind of optimizations. It's a bit depicted on the image on the right-hand side. So traditionally the data goes through the access stratum in LTE. So there we have this PDCP RLC MAC layers, and for access stratum, the terminating point is the base station and the UE. But for non-access stratum, it works above this access stratum, and for that, the terminating point in the network is MME, Mobility Management Entity. And the non-access stratum conveys this non-radio signaling between the UE and the network, and it transparently passes through the radio network. So non-access stratum does authentication, security control, mobility management, and bearer management. And as I said, access stratum basically transports the data over this radio connection and manages radio resources. For narrowband IoT, this optimization for data over this non-access stratum is also supported. And this means that the data basically passes transparently through the E node B or the base station. Also, in narrowband IoT, this access stratum can be used, and there's also a new optimization for that, which is called RRC suspend resume, which kind of minimizes the signaling needed for the UE to go from idle state to connected state. And yeah, there's also support for so-called non-IP, which enables the use of other delivery protocols than IP2. For layer 2 security, there is authentication between UE and the core network, encryption and integrity protection for both AS and NAS, and encryption of user plane data between the UE and radio network. And there's key management mechanisms for supporting mobility and UA connectivity mode changes. Yes, maybe we can move on to the next. So here we have a figure of the system architecture. So it's based on what is in legacy LTE, the evolved packet core. There's this mobile terminal is called for narrowband IoT. It's called Cellular IoT User Equipment, CIOT UE. And the EUTRAN handles the radio communications between the UE and this core network. And this EUTRAN consists basically of these E node Bs, or these are the base stations only. Some security properties, authentication and core network signaling security as in legacy LTE, security supporting optimized transmission of user data. There's encryption, integrity protection, user data for NAS signaling between the user equipment and the MME. But since there is no access stratum protocol PDCP. There is no integrity protection or encryption for the radio link itself between the UE and the base station. And then there's minimized signaling to resume this user plane security context in the radio network. And next slide.
Yep, Antti, just for information, you have 5 minutes left for questions. So,
okay, well, here short summary for this. So, deployment, the 3 deployment modes, coverage 164 decibels, 15 kilohertz tone spacing for downlink. For uplink, we have both single tone and multi-tone. Highest modulation QPSK, link peak rate 30 kilobits per second downlink, 60 in uplink, FDD, duplexing, MTU size 1500, transmission block size is 680 bits in downlink, 1000 bits in uplink maximum, minimum 16 bits both ways, and repetitions up to 2048 repetition downlink and 128 repetitions in uplink. Then there's this discontinuous reception cycles, and transmission power at least 24 dBms and 20 dBms. And the next slide, is there anything anymore? But this we can skip. And then there's a further release where 14 and further releases ongoing, and there are some features that are going to be implemented, but maybe that's not so important right now. Okay, I think that was the presentation.
Okay, thanks. Any questions in the room?
If there is none, I have one, Antti. I mean, for instance, Juan Carlos presented us the benefits that he expects from the work that will happen in this working group. So do you have some baseline of what this group could bring in the picture for NB-IoT? Do you expect, for instance, that the compression mechanism we're working on could be of interest for NB-IoT, or is it too late, or for our next generation?
I think, well, it would be good if this working group also could identify some problems here, but I think this non-access straight-to data over non-access straight-to signaling encryption for that, and also the compression for MME, because now in legacy ROC is used for access straight-to compression, and I don't know if it could be something else for this non-access straight-to data transmission. Or so at least this header compression is one thing. It would be good to look at if there's something that could be implemented better.
Okay. Thank you very much. Then, so we have there is a draft on there's a document on the NB-IoT part, and Stephen has already integrated parts from it. I will encourage also the group to read through Stephen's draft and to ensure that the things that are there will actually help you do the work, because as with Wyson and NB-IoT, there are such a huge systems that for me it would be really great if we can identify some scenarios, some use cases where we say, okay, here it is LPWAN. There is something that is meshed or high throughput. So there you can use things that already exist. But in these scenarios, then there is a really added value of these compression mechanisms. So thank you.
We think with this we will wrap up the working group in time. So thanks so much for being there. We urge you to read those 3 drafts in the next 15 days. I know it's hard, but we have this high pressure from, as you've seen, if we want to be successful in the market, we want to deliver within 1 year. So please read these documents in the next 2 weeks. We are calling for adoption for those 3 documents. And please respond on the mailing list with your review comments. Thank you so much. C'est toi ça? C'était là. Parce que je le nomme, c'est pour ça que je... Putain, c'était dit, j'y croyais pas quand il apparaît. Du bullshit, je sais jamais, il faut les ramener. Oui. On va dire ça, du bullshit.